Alright, so we have just a few more lessons to go for our ratios and rates unit. So we're on lesson 26, which is percent of a quantity. So remember, percent is that part out of 100 for our percent. And a quantity just is referring to a number. So we're looking at the percent of a number. Our I can statement is I can find the whole and part of a number when working with percents. So what does that mean? Well, when I'm working with percents, I'm either going to be given a part of something or the whole, and I'm going to find a percentage of it. So for example, I could have $80 and I want to find a percentage or a part of that. So maybe I want to find 10% of 80. So here I'm finding a part of my whole. Alright, so let's go to our first problem. 5 of the 25 girls on Pine Middle School's soccer team are 7th grade students. Find the percentage of 7th graders on the team. Show 2 different ways of solving for the answer. So let's start out with, well, something that we know easily. We know our fraction, so it's going to be part over a whole. And if I can write a fraction, I can easily make a percent. So here I have 5, that's my part, that 5, out of a whole. What is my whole? Well, that whole is that 25. So here, I'm going to start out with that fraction. And how do I make that fraction into a percentage? Well, I have 2 ways. My first way is I need to make this bottom number into 100. So I'm going to ask myself, how do I get from there to there? Well, I multiplied by 4, so then whatever I do to the top, I have to do to the bottom. Whatever I do to the bottom, I have to do to the top. So that's one way. I want you to look at this one, though. What do they do here? Well, instead of figuring out how do we get it to 100, I'm finding my unit, or how much it is per one. So they were going this way in this example. I'm breaking it down into that unit, that 1. And then I can easily figure out how do I get this into 100. And that's multiplying by 20. And you see, we get that same answer no matter which way we do it. This is going to be useful in a moment. Now, how do I get this fraction, part out of 100, to become a percent? Well, that's the easy part. All I do is I just add that percentage sign to my numerator, and that's my 100. Now, what if I wanted to create a model? Well, I'm going to start with this. Now, let's look. Why do I have 5 boxes? Well, my whole entire box is equal to what? My whole entire box is my whole. So that's that 100. Each box is going to be broken up into parts of 5. So now let's look. Why 5? Well, I'm going to shade one part out of 5. So let's take a look at what that's going to look like. Remember, when I have a percentage, my total equals 100. And what's this bottom portion going to be? Well, that is going to equal 5, 10, 15, 20, 25. Notice how my 100%, that means I have a whole, is equal to my denominator, since that's my whole as well. We can see where it comes into 5 pieces because there's going to be, when I simplify my fraction, 5 is my denominator. So that tells me how many parts there are in my whole, and this 1 tells me how big or how many pieces I'm going to shade in. So I'm going to shade in 1 part out of 5. And we see that 20% lines up right with that 5 as well. So now I can easily answer the question, find the percentage of 7th graders on the team. Well, I have 2 models. My computation, meaning I solve it mathematically, is 20%. My model also shows me that 5 25ths is the same as 20%. Alright, let's go to our next one. Of those 25 girls on the Pine Middle School soccer team, 40% also play on a traveling team. So let's write down my important information again. 5 out of 25. Again, this is my parts over my whole, and that 40%. Now, I want you to think, is this 5, that 40% down here? No, that 5 was for my different problem. That 5 was for my 5 people that are 7th graders. So my part's actually going to be different in this. That's what I'm looking for with this 40%. I'm looking for, what is that part? Well, I know right away it should be bigger than 5, since 40% is bigger than 5. So let's look. I'm going to do 2 ways of solving it computationally. My first one is I'm going to start out with that 40%. That's what's given me. I don't have my part, so I can't find out what? Can't find out my percentage. So I'm going to have to do a little bit different. I'm going to have to start out and go the reverse way. Notice here, I'm just going to clear it off for us. Notice here I start out with my what? With my fraction, and went towards my percent. Now, I'm going to start out with my percent, and I'm going to go backwards so I can find what? So I can find my numerator. So I'm going to make it a fraction, that 40%. Remember how I make a percentage as a fraction? I put over 100, and then I take off that percent sign. Can I simplify this somehow? Yeah, I can. I'm going to simplify it to what? To 10 over 25. I want you to think, why don't I simplify it to 4/10 or 2/5? Well, the reason why is because my whole is at 25, so I just want to stop there. So how did I get here? Well, I divided this by what? By 4, and I divided this by 4. I had to get this to 25 because that's how big that whole is again. So I can ask myself, how many of the girls on the middle school team also play on that traveling team? Well, it's my part. It's that 10 part, or those 10 people also play on that traveling team. Alright, so let's make my model. Again, what is my model going to look like? Well, it's going to be easy. I know this part's going to end with 100. And why do you think I made it 5? Well, I'm actually just going to be copying this exact model down because it was very similar. So that's why I have the exact same thing, only this time there's something different. I shaded in 2 parts. Why? Well, because I'm looking for that 40%. So now the top part of my number line, not my number line, I'm sorry, of my tape diagram is my percentages. The bottom part is my parts. So here, 40% is 10 parts. So you can see my 10s match up as well for both my computation, solving it mathematically, and with my model. Let's try our next one. So here, so it's Pine Middle Schoolers again. They won 80% of its games this season. If the team won 12 games, how many games did it play? Well, this one is different than our other two. Why? Well, it's because I'm going to be given a percent again. It's that 80%. I know its part is 12, but I don't know the whole, do I? No. I know its part, they won 12, but I don't know how many total games they played. That's what I'm looking for. So here I'm going to have to do something different. I'm going to start out again with that 80%, and I'm going to turn it into a fraction. So I put over that 100, and I've labeled it for us just so we can see our visuals. That's 81 over 100 is my total. So my total games though, and now what do I need to do? I'm just going to simplify it. So I divided by 10. How do I get from here to here? Divided by 10. And divided by 10. Now what do I need to do next? Uh-oh. I want you to look at this, see if you can figure out where my mistake is. Do any of you see it? This part would be the amount lost. 1 lost, 5 wins. So what do I need to do? I need to change it to 4. How did I get that? I divided by 2. And divided by 2. Notice if I want to find the amount they lost, I would just do 5 minus that 4, and that would give my remaining 1 game, which is that lost one. Alright, let's continue. This part, hopefully you'll be able to make it a really easy connection. I want you to look at this. I'm going to multiply my denominator and numerator by 3. Remember, whatever I do to the bottom, I have to do to that top. Now, why did I pick 3? Well, hopefully you see that connection. I need to get my numerator to equal that 12 parts, because that's how many games they won. And then 5 times 3 is that 15. And then if I keep my labels the same, you can notice I have my 12 parts. It all came from that 80%. And my denominator, remember, is a fraction. That denominator is your total. Parts on the top, total on the bottom. So how many total games did they play? Well, they played 15. Here's a model just to demonstrate as well. I'm going to break it up into 5 parts. Why? Well, when I simplified my fraction right here, my total number of parts was that 5. So I'm going to make my labels. The top's my percent. Since it's by 5s, I'm counting by 20%. That bottom is going to be what? It's going to be 3 this time. Why is it 3? Well, hopefully you notice it's 3 because here my total amount is 15. Previous example, the total amount was 25, so I would divide that by 5, which equals 5, which means each time I was counting by 5. This time, though, my total is 15, so I divide it by 5, and it gets 3. So now let's look at our remaining. I'm looking for that 80%, and then I look for the number that's straight below, that 12. So I see these match up, but now, since I'm looking for that how many games total did it play, I'm looking for that 100%. I go straight down and I see 100, so the total amount they played is that 15. So I'll notice that my answers are still the same. So what's wrong with this right here? Hopefully you notice that the 12 is not my answer. That's just showing me that they line up. So this line, or that circle, should be right over here. Alright, let's continue. So here's our next problem. There's 60 animal exhibits at the local zoo. What percent of the zoo's exhibits does each animal class represent? Well, let's highlight that key information. 60 animal exhibits. That's going to be my total. And I'm looking for the percent. So this first one's going to be easy. I'm going to take all of these. I'm going to write them as my part over whole. And then what am I going to do next? I'm going to see if I can get that denominator to equal 100. So let's look at this first one. 30 is my part over my total, my whole. Well, it's saying there's a total of 60. So hopefully you can recognize that will simplify to 3 over 6, which is equal to 1/2. And hopefully we know by now that 1/2 is 50%. So let's check it. And look at that, exactly what we did. They just did it a little bit differently instead of simplifying down to 1/2. Now we are going to go to this next one. 15 is my part. What is my whole? That whole is the total amount, which is 60. So here I'm going to what? Divide by 3 and divide by 3. Hopefully you see 3 goes into each. 5 over 12. Do you see a problem here? Hopefully you do. Should be 5 over 20. Now I have an easy step. How do I get this 20 to become a 100? I multiply by 5, which means I multiply this by 5. which equals 25 over 100, which is 25%. And look at that, our numbers match up. This next one we're going to solve slightly different, 12 and 3. So here I'm just going to write these numbers here so I remember, and my total is 60. I'm going to show you how we can also do this using a ratio table and why it works. Here's going to be my parts. So the parts of the zoo exhibit. And this is my total exhibits. So what do I know? Well, all of these are equivalent ratios. 30, 60, 5, 10, 50, 100. Those are all equivalent ratios. What do I know about all of these? They're all equivalent ratios as well. So what I can do is I can make a ratio table of equivalent ratios of these. 12 over 60. It's the same thing as my parts over whole. And then what I'm going to do is I can make equivalent ratios, which means if I divide this side by something, I have to divide this other side by something. So let's divide it by 2. So this is going to be 6 over 30. Now hopefully I can see something I can easily divide again. 6 goes into each as well. So this is going to be 1 over 5. And what's my goal? Well, remember my goal is I'm trying to get this to equal 100. Remember, I want that denominator to equal 100 for a percent. So how can I get from 5 now to 100? Well, I can multiply by 20, which means what? I have to do the same thing to that opposite side. And look at that, my part is 20, my total is 100, so I can rewrite that as that fraction. And now, since my denominator is 100, I can easily find out that that is my what? That is my percent. Now look, I'm also getting that 20% as well, and I did it slightly differently. But you'll notice there's still simplified fractions. You'll notice simplified fractions is the exact same thing as making that ratio table. So let's try our next one, this 3, but we're going to use this ratio table again. So this 12 is gone. We already solved for that. So now we're going to do 3. My total is still 60 exhibits. So I'm going to basically like this. 3 out of 60 equals 100 out of my percent. And that's what I'm looking for. So my goal is what? My goal is to somehow end up with 100 on my total exhibit side. So let's start off with, what can I simplify this to? Well, I can easily see that I can divide each side by 3. So this gives me 120, and look at that already. That first step, I can easily see that now all I have to do is multiply by 5. Whatever I do to the left side, whatever I do to the right side, I have to do to that left side. And look at that. There's my 100. And my part is at 5. So my answer is going to be 5%. Let's just check it out, seeing how we did it on this side. And notice this right here, that 1 over 20. Actually, let me pick a highlighter. This 1/20th. Look at what we have here. 1/20th. Do you notice something similar? 5 over 100. Hey, it looks like equivalent fractions is what we've been doing this whole time with those ratio tables. Alright, let's look at this next one now. A sweater is regularly $32. It is 25% off the original price this week. This is my question now. Let's look at it carefully. Would the amount the shopper saved be considered the part, whole, or the percent? Well, my part over whole, and percent. That's the three things they're asking me to compare. Well, I know it's not the percent because my percent is 25. I'm not saving $25, so it's not the percent. So I'm left with my part or my whole. It normally costs $32. Are we saving 32? No, I'm not saving 32. So the part is how much I'm going to save. If I save $8, if I save $10, if I save $16, that's my part, how much I save. So how much would I save by buying this sweater for the week? I'm going to show two methods for finding my answer. Here's my two methods. Now let's discuss them. Here's my 25%, comes from right here, and I change it to that fraction. So I put it over 100, 25, and I'm just simplifying. I'm dividing by what? 25. So there's that 1/4. And then what do I need to do? Well, I'm going to multiply it by however much it cost. So it cost 32, and I'm saving 1/4 of it. So I'm going to multiply it by that 1/4. And look at that, it equals $8. Now if this computation way doesn't work very well for you, I can use a different method. So that's why we've been showing you two methods. Notice I'm doing the same thing. My percents are on the bottom, and there's these numbers on the top. My hardest part starts with, how do I know how many boxes there are? Well, remember, I'm simplifying my fraction both ways. I'm taking my percent, I'm turning it to a simplified fraction. This bottom number is my whole. How many parts do I need to make up this whole? I need 4 parts. There's 1, 2, 3, 4. How big is each part? Well, it's going to be 25%, because 25 plus 25 is 50. So if I add 25 4 times, I get that 100. Now, here's my next question. How do I know how big this top portion is? Well, my total is how much it would normally cost. That's where this 32 came from. And then what do I need to do? Well, I'm doing 32 divided by how many parts there are. There's 4 parts. So that means each part is $8. And then all I do is I look for where is that 25%, and I'm going to look straight up and see what number there is. So there's $8. So notice that my 8 matches my 8. All right, let's look at this next one. It's almost the same but slightly different. Pair of jeans was 30% off the original price. The sale resulted in a $24 discount. So my first question is the original price. I'm going to highlight that. The original price, consider the whole, part, or percent. Well, let's look back on this side. Part over whole and percent. Those are those 3 words that's asked me to consider: whole, part, percent. Well, I know right away it's not the percent. Why? Well, because it's saying 30%, and 30% is not 24. So right away, I know it's not going to be my percent that I'm going to be looking for. So I'm left with my whole or my part. Well, this is my key phrase. It says, the sale resulted in a $24 discount. That doesn't mean that it cost $24 originally and then it was taken off. That $24 is how much I'm saving. So if I'm saving a portion, then that means what? It means it's this top part. I'm saving that much. Doesn't cost that much total normally. It's how much I'm saving. So what I'm left with is this whole. That whole price is how much I would normally pay. Normally you would pay what? Normally you would pay 100%. So that's another way. The original price is always that 100%, or how much you would normally pay. Okay, so now I have this question again. What was the original cost of the jeans before the sale? Show 2 methods for finding your answer. So here I'm going to show you both methods, and then we're just going to discuss it. So my first one is this 30%, and all I'm doing is I'm taking this 30%, putting over 100, and I'm just simplifying it to 3/10. How did I do that? Hopefully I don't have to show you, but just in case, I will. I'm dividing it by 10. Okay. Now, notice up here, this 3, I needed to match what? I needed to match that 24. I know what my part was in this example, so I need this part to equal 24. So how did I get that 3 to become a 24? Well, I multiplied it by 8. And whatever I do to my numerator, I must do to my denominator. So here I have that $24 discount, and here I have how much it would cost normally, that total. Now maybe you're saying, I don't understand that. So that's why we have these picture options. We'll also use a ratio table on our next one too to remind you of those ratio tables. So I'm going to start with a box, my tape diagram, and on the bottom I forgot to put all of these. These should all be percents. So that was my mistake. And remember, one whole is 100%. And what's my whole? Well, actually, this time, I didn't know what my whole was. I didn't know what any of these were. All I knew was one tiny thing. And what was that thing? Well, I knew that 3 parts out of 10, so 1, 2, 3 parts out of 10 is what? 3 parts out of 10 is this 24. So I knew this part right up here was that 24. Now I can find out how big each box is because I can do 24 divided by 3 equals 8. So then I knew each box is 8. So that would be 8, 16, all the way up here. And so now I'm asking for that original price. Original price means that 100%. So I can look and I can see right here, it's 100% is 80. And I'll see that these both match. So I've checked my answer. All right, let's look at this next one. Purchasing a TV that is 20% off will save $180. So now I need to name the different parts with words. So I have 3 parts like always. I have part, whole, and percent. Well, hopefully you can look and you can see that 20% is going to be my percent. So that's going to be my easy one to match up. So I'm left with 2 mystery things. My part and my whole. Well, I'm going to fill in what I do know. This 180, that's not my total price. That's how much I'm saving. So it's how much I'm saving is that 180. It's not the total price, it's just a portion of it. So that's going to be my part. And if I remember from this previous lesson, my original price is always that 100%. And that 100% means it's a whole. So now that I've labeled my parts correctly, let's look and answer this question. What's the original price of the TV? Show 2 methods for finding your answer. Well, here's my first method. I know my percentage, and I'm just taking that percent and I'm converting it to a fraction. Now notice here, I didn't simplify. I could if I wanted to. I could simplify it to 2/10, or I could simplify it to 1/5. But I need to keep in mind, just to save me some time, what am I trying to get it to equal? Well, I'm trying to get this top portion to equal what? 180. So is there an easier way I could get this to become 180? Yeah, I can just multiply it by 9. And when I do that, here's my part, is that 180, and here's my whole. So what does that whole mean? Well, that's its original price. And look, that's what I'm looking for, that original price. So my original price is 900. I'm also going to show you how it would work if I also kept simplifying it. So let's say I divided the top by 20, divided the bottom by 20. Would I still get the same answer? Well, here I would get 1/5. So I have 1/5, and I need it to equal 180 up top. So how do I get from 1 to 180? I multiply by 180, which means whatever I do to my numerator, I have to do to the denominator. And now I'm just going to do my math off on the side. 0, 0, carry that 4, 900, and look at that. 900, that's how much it said on my other example as well. That would also cost 900. So this way just made an extra step for me. But remember, they're all equivalent fractions, so it doesn't matter if I make it larger or smaller first. So now I'm going to show you with that ratio table. I'm starting out with my part to whole, and I'm trying to get what? I'm trying to get this whole to equal 180. So let's now divide it. How did I get from here to here? Well, I multiplied by 2, multiplied by 2. How did I get from here to here? Multiplied again by 2, multiplied again by 2. How did I get from here to here? Multiplied by 2, multiplied by 2. So here I'm going to run into a problem though. This is really close to that 180, but it's not quite. So this is what I know. My part is 160, then it's going to cost $800. I need this to go up just by 20 though. Is there anything here that I have that can help me? Yeah, actually this can. This tells me if it's $20 I'm saving, it's an extra $100 I would be paying. So if I add this to here, then I have to add this to here. So I would add 20, and I would add 100. Remember, this is saying whenever I increase by 20, I have to increase by 100. And look, you will notice my 180 that I've had in all my examples, and that 900 for the original price. So I have three ways. I have ratio tables to solve these kind, tape diagrams, and just my regular computation. Alright, so our lesson summary. Models and diagrams can be used to solve percent problems. Tape diagrams, 10 by 10 grids, double number line diagrams, and others can be used in a similar way to solve them with ratios to find the percent, the part, or the whole. So basically what we just did here, we have many different models to choose from to solve them. I know it's hard, but you have to persevere. You have to think, how can I set up this problem to solve it? Alright, here's your exit ticket. So what you're going to do is first you're going to find 40% of 60 using, and since you're on the computer, you're going to use just one strategy. And since you're on the computer, I also don't care if it's a model or diagram. Just submit your answer. Alright, and this next one, same thing. 15% of an amount is 30. So just remember on this, all of our problems, if you need to go back and rewatch, that's okay. If I can find part, whole, or percent, I can figure out where does 15 go in relation, where does 30 go, is that my part or whole, then I have enough information to solve all of them. Alright, when you are done, we're going to skip this. When you are done, I want you to go on Khan Academy. You're going to do one lesson. I know some of you haven't been doing them, so please make sure you do. And then when you are done with Khan Academy and you've completed one lesson, then you may go to math games. All right, good luck, and I hope you had fun today.